right, new unit. So we are on chapter 8, and I'm kind of excited about this. There's not a lot of math in this unit. So really the big thing that you're going to have to remember in this unit is factoring. So let's go through some vocabulary because this is going to be really important as we set these up. So we are dealing with polynomials and end behavior. And what end behavior means is what happens at the end of the function. So if I draw some graph and it looks like this, I've got arrows on this graph. And so what happens is this, as it keeps going, and this, as it keeps going, is going to be my end behavior. So when I talk about end behavior, it's like what happens if we go out to infinity in the x-axis or negative infinity on the x-axis. So what happens if I just keep going on and on and on in both directions? Okay, so when I talk about end behavior, think about what's happening at infinity or negative infinity in the x direction. Okay, we're also going to talk about what happens in the y direction. So that's also important, but it's really as the graph just keeps going in the x direction, what's happening. So as I keep going here, this is going up, right? And as I keep going this way, it's going down in the y direction. Okay, so let's come back to that. So first thing we have here is some definitions. So definition of a polynomial. So polynomial, poly means many. Oh, and nomial means terms. So if you look at this polynomial, so many terms, right, I have all of these different terms. So normally what we would try to do is combine like terms, but none of these are the same. I can't combine x to the 5th with x to the 4th. I can't subtract those. They're different, okay? So if I have a monomial, this means that I'm only going to have one term. And a binomial means 2, and a trinomial means 3. And all of these together are individual types of polynomials. So these are all polynomials, but these are some specific ones. So we know what a trinomial is. We do this when we have guess and check, right? Trial and error when we factor. So that would be a trinomial. So x squared minus 3x plus 6, something like that. So I have 3 terms, 1, 2, 3. Okay, so now let's look at this polynomial. I've got many terms, so it's not one of these specific ones. I've got all of these different terms. And the first thing that we have is the degree of the term. Now, this is a term, and this is another term, and this is another term. So that all of these different things are terms. So if we want to know the degree on the term, what we're looking for, the degree means the exponent on each term. So what we would say is the exponent on this would be 5. So this is a 5th degree polynomial. The exponent on this is 4. So this is 4th. This is 3rd. This is 2nd. This is 1. And this is actually a 0 degree. If I had an x here, so 5x to the 0, we know anything to the 0 power is 1. So this still has a degree on it. It's just that we know that anything to the 0 power is 1, so we would say that this is a 0 degree term, okay? So the degree of the polynomial, this is a little bit different. The degree on the polynomial is always the biggest exponent. So on this one, my biggest exponent is this guy right here. So this is going to be a 5th degree polynomial. Now we have all these other ones, but the degree of the polynomial means the degree of the whole thing versus the degree of the term, and the term is each individual one. Okay? Now, the leading coefficient is the number, so it's the coefficient, which is the number in front of the highest exponent. Now here I use the word biggest, but we could also say the highest. It's the biggest number, so it's the highest. So in this one, this is a 5th degree polynomial because that's my biggest power, and my leading coefficient here is going to be 10. That's the number, the coefficient that's in front of that exponent. Okay, so let's do a little bit of practice. So you're going to want to turn your paper here. So what we're going to do is we're going to fill out this form, and we're going to do just fill out this part before we get to the calculator. So remember, this is the degree of the polynomial. So each of these terms have one, but I'm just going to look at this. So the degree of this polynomial is a second degree polynomial. And the leading coefficient is the number that's in front, so that is also a 2. If I look at this, I look at all of my exponents. This is a 4th degree polynomial. And the leading coefficient here is an implied 1, so it's just 1. Here, this is also a 2nd degree polynomial. This is my biggest one, and my leading coefficient is -4. And here, that's my biggest one, so I have a 6th degree polynomial, and my leading coefficient is -3. Okay, so let's go in here and graph this now. So what it tells us up here is we're going to use our calculator to graph this. So we're going to go into y equals, and you're going to have 2x squared minus 2x minus 11. And it gives you a graphing window. So if I go in here, I'm going to go to window. And then this tells me my x bounds. So I want to go from -5 to 5. Always keep your scale at 1. And your y bounds are -20 and 20. And again, my y scale is 1. So if I graph that, here's what I see. So I'm not going to get super specific on this. Really what I'm doing is I'm just looking for something that's going to look like this. Okay, so my end behavior, remember we talked about end behavior, it's what happens out here at infinity and negative infinity. That means I'm going up and I'm going up. Okay, now this is just what's happening at the end, up, up. And so we're actually going to say that this is an up, up end behavior. Now the number of turns is the number of times I'm changing direction. So if I go down this way, this is 1. And I go up this way, this is 2. So I have 2 turns on here. So if I have 2 turns, so I switch directions twice, so 2 direction changes. We are going to say that only changing here 1 time. So I have 1 turn. So what I have here is that this is going to be, if we see we have 2 turns and the highest degree of my polynomial, have a 2nd degree polynomial, we're going to say that this is n minus 1. This is how we calculate our number of terms. I like to look at it as a direction change, 1, 2, but when we look at the turns, we only have 1 turn, and the way that we can calculate that is 2nd degree, so 2 minus 1, which is 1 turn. Now, my number of zeros is where I'm going to cross the x-axis. And we did this when we talked about polynomials, or sorry, quadratics. So we had a quadratic where I crossed the x-axis. So on this one, I'm going to cross the x-axis here, and I'm going to cross the x-axis here. So I have 2 zeros. And I don't care right now where those zeros are. I'm just looking at the graph. That's all we're looking at right now is the graph. Okay, so let's look at another one. So go ahead and type this into your calculator. So what I have is x to the 4th Oh no, that's why you should always look. Okay, so let me check. All right, so we're good. So now I'm going to graph it. I'm not changing my window. I'm just going to graph it. Okay, so now it looks a little more funky. So let's go ahead and sketch that graph. So again, I don't care about where my values are. I just want the graph to look the same. So if I look at this and I look at what I sketched, they're about the same. So what happens to my end behavior? Again, it's up, up, right? So here, it's up, up. All right, so I'm going to look at this, and this is a 4th degree polynomial. So my number of turns is going to be 4 minus 1, which is 3. So let's count these. I have 1 turn here, 1 turn here, and 1 turn here. So this is right. I have 3 turns. So this checked out, and this also means I have 4 direction changes. So if I count these, 1, 2, 3, 4. Okay? Now, number of zeros. So I'm just going to go in here and I'm going to circle them, and I have 1 here, 1 here, 1 here, and 1 here. So I have 4 zeros. And what we need to look at is that we have this degree of 2, I have 2 zeros. A degree of 4, I have 4 zeros. Now, we're going to get into this, but this is not always going to be a 0. So when you look at that strategy, you have to say that this is going to be our max number of zeros. All right, let's try another one. So go in here, I'm going to put in this new one, so negative 4x squared plus 8x plus 3. And I'm going to go ahead and graph it, and then I want to sketch that. So I have something that's going to look like this. Now, we already knew that. You already know that because this is an x squared, so we know that this is going to be a u, and this is negative, so we know it's going to be down, which is exactly what we have. So my end behavior here looks like this, so we would say down, down. All right, so second degree polynomial, so I'm going to have 2 minus 1, so I'm going to have 1 turn. That's this point that's right here. I have 1 turn, or I can look at this as 2 direction changes. I also have 1, 2 zeros. Now, we said that this is true because remember, if we go back, we have a second degree polynomial, so I should have 2 zeros. Okay. Last one here for the evens. So if I plug this in, negative 3x to the 6th plus 13x to the 4th minus 15x squared. And now I'm going to graph it. Okay, so let's sketch this guy. So I have something that looks like this, and then goes up here, and then goes like this. Okay, so what do I have? What is my end behavior? My end behavior is down, down again. And this is a 6th degree polynomial. So what that looks like is 6 minus 1, which is 5 turns. So I have 1, 2, 3, 4, 5. That worked. Now, this is one where it's a little bit off. Remember, the 0 is where I cross or I hit the x-axis. Well, look what happens. I only hit the x-axis 1 time. So if you remember up here, I said the zeros, I have 4 zeros, and this can be my maximum number of zeros. So what could have happened is I could have had 6 zeros, but with this graph, I only have 1 0. Now, I'm going to make a little note right here. My max zeros could have been 6. I could have had 6, but when I graphed it, I really only had 1. All right, so that's an important concept. Okay, let's flip this guy over and look at some odd degrees. So let's fill out our chart here first. So this is my biggest power, so it's 3. My leading coefficient is 1. Here, my biggest power is 5. My leading coefficient is 2. Here, my biggest power is 3, so this is a 3rd degree polynomial, and I have a negative 4, and this is 7, and this is negative 3. Okay, so actually let me point something out up here. What you're going to notice, and these were all with evens, is this leading coefficient is 2, but it was positive. And this was 1, it was positive. This was negative, and this was negative. Now, let's go back to what we know about our quadratic equation, right? So we know that this is going to be a u, and it's going to go up. Well, that's what I have. Why? Because this is positive. So this is x to the 4th. It doesn't matter that it's 4. What you see is because this is positive, we end up with an up-up situation. All right? Here's a quadratic. We know that this goes down, and this is what we have, down, down. This was negative. And this one's also negative. So even though this is not 2 and it's 6, it's still even, right? 2, 4, 6, those are all even. And so this is going to be both arrows go down, down. Okay. okay? And we're going to summarize this a little bit more on the next page, but now let's go in here and look at these. So I see that this is positive, and this is positive, and this is negative, and this is negative. All right, so let's go graph that guy and see what it looks like. Let's see, x cubed minus x squared minus 3x plus 1. I'm going to keep the same window, and that's my graph. So here's what I have. I start here, I cross, I cross, I cross, and my graph looks like this. Okay, so my end behavior now, these are not going the same direction. So I have one that goes down and one that goes up. So we would say down, up. Okay, my number of turns, that formula stays the same. So n minus 1. So if I look at this, here's my degree is 3. So 3 minus 1 equals 2. So I have one turn here and one turn here, right? And then this is my direction changes. Direction changes. So my direction changes happen 3 times. 1, 2, 3. So that worked. All right. So based on what we know with evens, I should have a maximum of 3 zeros. So I have 1, 2, 3 zeros. All right, let's do another one. So this is 2x to the 5th minus 6x to the 4th minus 2x cubed minus 14x squared plus 5. Oh, it should be plus right here. It's always good, especially when you're doing this, to go back and check, because this is twice now that I've made a mistake. So let's hit graph. Right, so this has got a lot of funky stuff going on. So I'm going to start over here, and it's going to go like this, and then come up, and then come down, and then come up. So it looks like that. Nope. There we go. So what is my end behavior? Again, it's down, up. Same thing. I have a down, up behavior. My number of turns. So this is a 5th degree polynomial, so 5 minus 1 should be 4. So I have 1, 2, 3, 4. So that checks out. I also have 1, 2, 3, 4, 5 direction changes. All right, I'm going to look at my zeros now. So if I look at my zeros, I have 1 here, and 1 here. So I only have 3 zeros. I'm going to make a note, though. I could have had a max of 5 zeros. So if this guy would have crossed over, that would have given me another 0, right? If this guy would have crossed over, it would have given me another 0. So because these didn't cross, I only had 3 zeros on this graph. All right, we've got 2 more here. Let's get those knocked out. So I have negative 4x cubed plus x squared plus 3x minus 1. All right, so what does this look like? Looks like this. All right, so now if I look at my end behavior looks like this. So we would say this is up, down. We started up, we ended down. All right, so this is a 3rd degree polynomial. So I have 3 minus 1, so I need to have 2 turns, and I have 1 turn here and 1 turn here. So that worked. Now, let's look at my zeros. I have 1 0 here, and I have 1 0 here. So I only have 2 zeros, and I could have had a max of 3. All right, last one. So negative 3x to the 7th power. Hold on, let me just do the whole thing. It's actually faster for me to do that. Negative 3x to the 7th plus 8x to the 5th minus 18x cubed plus 6x. All right? So let me graph that guy. I'm going to do something real quick. All right, so here's what I get. So I just messed around with my window, so your window is going to look different. But what do I see here? I have another up-down situation. I have, in this case, it looks like I have 2 turns. So let's go back and look at that again. So I have 2 turns, and then I have 1, 2, 3 zeros. Okay, let's talk about what's happening here. So what we see is that when we have, these are all odd degrees, and when I have all odd degrees, but my leading coefficient is positive, I have a down-up situation. If I have odd degrees and my leading coefficient is negative, I have an up-down situation. So this is not new, and let me show you how you know this. If I look at a function that we did in the last unit, a function like x cubed, so x cubed, here's my parent function, and my graph is going to look like this, right? So my normal graph, so a degree of 3 with a positive leading coefficient is going to be down up. If I have y equals negative x cubed, then what happens is my graph looks like this, and it goes up down. So when you see this and we say that this is odd negative, so I'm going to write this down, odd negative, we know we're going to have a situation where we go up down. So it doesn't matter that it's 7 and we're going to have extra turns or we're going to have extra stuff in there. What's important is what happens at my end behavior. All right, so take this back to what you know. Same thing over here. Just take this back to a quadratic. If this is positive, you know it's up, up. It doesn't matter if it's a 6th degree. This is still even. So we're going to say this is even negative. So even negative is always going to be the same direction, down, down. All right, so let's summarize this in this table right here. So we have this table, and all we're doing on this is we're going to summarize all of this. So if I have an even degree, so x squared, x to the 4th, x to the 6th, these are all even, and we're going to say that they go in the same direction. So if it's positive, I'm going to say up, up. If it's negative, I'm going to say down, down. And so this would be up, up, same direction, they're both going up, and this would be down, down. And the way I want you to remember this is just think about a quadratic. That is going to be my up, up. So this is going to be even, positive. And this, I should have not used that color. Here, I'm going to use this color. This is going to be even, negative, down, down. All right? So if it's an odd degree, so an odd degree includes x, right? X cubed, x to the 9th, these are all odd. Then these are going to be opposite directions. So if the coefficient is positive, then it's going to be down, up. If it's negative, it's going to be up, down. So let's go over here and think about how do we know this. We could use anything. I'm going to use cubed, even though we could just use an x. All right? So if it's a positive coefficient, I'm going to have something that's going to look like this. This is odd, positive. Okay? If it is a negative coefficient, it's going to look like this. This is odd, negative, up, down. All right? So just go back to the functions that you know. All right, so what is all of this saying? So what this is saying is that the degree of the polynomial determines the maximum number of turns. So we just did that. We said the maximum number of turns is going to be n minus 1, right? And the maximum number of zeros. And remember, the 0 is where we cross or we hit. We don't have to cross it. We just have to hit the x. So it's the x-intercepts. So because of this, the maximum number of turns is going to be the degree minus 1. And we did this over here. I was using the variable n, but what this n is over here with your degree. So n minus 1. And the maximum number of zeros is the degree. Now, keyword here, keyword is maximum. The maximum number of terms and the maximum number of zeros. Now, we saw that on our last one here. So this tells us that we have 7. So I could have had a total, So I could have had 6 turns. I didn't, right? I only had 2. And this says I could have had a max of 7 zeros. And again, I didn't. I only had 3. So when we're talking about the number of turns and the number of zeros, that's always the maximum number that you can have. All right? So let's talk about what a polynomial looks like. So everything that we graphed over here, all of these are all polynomials. So if we look at this, this is not a polynomial because I have this break that's here in the middle. Okay? This is not a polynomial because what I have here is not this nice, smooth, flowy graph. I have something funky here and here. So when we have a function like the absolute value of x, what we have is something that looks like this. This is not a polynomial. We know that because this is a sharp turn. We also know that because I don't have a power on this guy, right? It's just the absolute value of x. It's not x squared or x cubed. These have a power. These have a degree. All right? This is a polynomial. It's a nice smooth curve, and this is also a polynomial. Okay, so let's do a couple of examples here. So when we have this, what we're going to do is we're just going to analyze this graph and then sketch a possible graph. This is not necessarily what it would look like if you put it in your calculator, because remember, we could have a different number of turns and zeros, but we're just going to do a possible one. So if I look at my degree here is 4. And I'm going to say that 4 is even. And when it's even, it's going to be the same direction. So all of these things you need to think of when you're looking at this power. My leading coefficient is negative. So what I have here is even negative. So even negative is going to be down, down. So go back to x squared. We know x squared is going to be the same direction. We know that when this is a negative number out here, it's going to go down. So my maximum number of zeros is the degree, which is 4. And my maximum number of turns is 4 minus 1, which is going to be 3. Remember, this is the degree minus 1. Okay, so what's that going to look like? That means I'm going to go down, down. So I'm going to have 2 arrows here. They're going to end up down, down. And I could have 3 turns and 4 zeros. So this would be 1 turn, 2 turn, and 3 turns. So let's count my turns. Here's 1, here's 2, here's 3. All right, so that would be 3 turns. And then my zeros, 1, 2, 3, 4. That works. All right, my degree here is 3, which is odd. My leading coefficient is positive. So if it is odd positive, it goes down, up. My maximum zeros is going to be 3. And my maximum turns is 3 minus 1, which is going to be 2. Okay, so how do I start? Down, up. This is my end behavior. This is what's going to happen, down, up. And I know that I'm going to have 2 turns. So this is 1 turn, this is 2 turns. All right, here's 1 turn, here's 2 turns, maximum of 3 zeros, 1, 2, 3. Okay, let's look at this one. So this is a degree of 3. Now, this is not written in standard order. So just double check and make sure that you've got these written in standard order. So this is a degree of 3, which is odd. And I didn't circle this very well, but my leading coefficient includes this negative. So this is going to be negative. So if I have odd negative, my line would look like this. My maximum number of zeros is 3, and my maximum number of turns is 3 minus 1, which equals 2. Okay, now the fact that this is a fraction and has an x squared and all of that, that doesn't matter. We're just looking for, this one is the biggest. All right, so I'm going to start here. Here's my end behavior. I'm going to end here. I can have 2 turns, 1, 2. Right, so here's 1 turn, here's 2 turns, and I have 1, 2, 3 zeros. All right, So this one, I'm going to do this one a little bit different. So if I look at all of this, this is my degree of 6, which is even. My leading coefficient here is 5, and 5 is positive, so even positive is going to be up, up. My maximum zeros would be 6, and my maximum number of turns is 6 minus 1, which is 5. Okay, so up, up. I'm going to start here, and I'm going to start here. Now, with every one of these, every time I've had a turn, I've crossed the x-axis. But remember, this is a possible sketch. So on this one, I'm going to say, you know, I'm not going to cross the x-axis this time. So I'm going to go down here, and I'm going to go, remember, 5 turns. So 1, 2, 3, 4, 5. This should kind of be going over here. So let's look at this. I have 1, 2, 3, 4, 5 turns. So that worked out. And this has a maximum of 6 zeros. I have 1, 2 zeros. So here I have a max of 6, but I only have 2. Okay? This is okay. It's okay to have this. This is a possible sketch, right? 1, 2, 3, 4, 5 turns, but only 2 zeros. Now, if I was going to cross the axis every time, if I brought this up and brought it down and brought it up and brought it down, then I would have had 6 zeros. Okay, so here, all we're going to say is what we know about this guy. So what I know is that this is down, up. So because these are opposite directions, then I know this has to be an odd function. All right, and because I'm going down, up, I know that this has to be a positive leading coefficient. All right, let's talk about this one. So this one is down, down. So if this is down, down, I know that these are the same direction, so this has to be even. And because they're both down, down, I know that the leading coefficient has to be negative, right? So think about this, negative x squared. It goes down, so the leading coefficient has to be down. Okay, you get to practice some of this on your homework.